Module 4, Graphs and Relations. Question 1. The graph below shows the membership numbers of the Wombatong Rural Women's Association each year for the years 2008-2018. Part A. How many members were there in 2009? So we look at 2009, we go up until we meet the line, and then across, and that is 60. So 60 members. Part BI. Show that the average rate of change of membership numbers from 2013 to 2018 was -6 members per year. Let's mark 2 points of interest. First of all, in 2013 there were 62 members, and in 2018 there were 32 members. So we calculate the gradient of the line between these 2 points, which is going to give us the average rate of change. That is 32 minus 62 over 2018 minus 2013. That is -30 over 5, which is -6 members per year. Part 2i. If the change in membership numbers continues at this rate, how many members will there be in 2021? Since the membership numbers decreased by 6 members per year, the decrease will be 6 times 3 years, which is 18. In 2018, there were 32 members, minus 18 equals 14 members in 2021. Question 2. Each branch within the association pays an annual fee based on the number of members it has. To encourage each branch to find new members, 2 new annual fee systems have been proposed. Proposal 1 is shown in the graph below, where the proposed annual fee per member in dollars is displayed for branches with up to 25 members. Part A. What is the smallest number of members that a branch may have? From the graph, we can see that the smallest number of members is 3. Part B. The incomplete inequality below shows the number of members required for an annual fee per member of $10. Complete the inequality by writing the appropriate symbol and number in the box provided. We look at the graph again, and that number is going to be 10. Because there is a dot at the end of the interval, then we have less than or equal to 10. Proposal 2 is modeled by the following equation. Annual fee per member equals -0.25 times the number of members plus 12.25. Part C. Sketch this equation on the graph for proposal 1 shown below. We are going to start from the intercept with the vertical axis, which is 12.25. Then we calculate the annual fee per member for 25 members. So the annual fee per member equals -0.25 times 25 plus 12.25 equals 6. So the new point has coordinates 25 and 6. We can now draw the line between the 2 points. Part D. Proposal 1 and Proposal 2 have the same annual fee per member for some values of the number of members. Write down all values of the number of members for which this is the case. For this, we are going to look for the points of intersection between the 2 graphs. The first point has coordinates 9 and 10. The next point has coordinates 17 and 8. And the last point has coordinates 25 and 6. So the number of members is 9, 17, and 25. Question 3. Members of the association will travel to a conference in cars and minibuses. Let X be the number of cars used for travel. Let Y be the number of minibuses used for travel. A maximum of 8 cars and minibuses in total can be used. And this is inequality 1, X plus Y less than or equal to 8. At least 3 cars must be used, and this is inequality 2, X greater than or equal to 3. At least 2 minibuses must be used, and this is inequality 3, y greater than or equal to 2. Part A. Each car can carry a total of 5 people, and each minibus can carry a total of 10 people. A maximum of 60 people can attend the conference. Use this information to write inequality 4. So we have 5 people per car, that is 5x, 10 people per minibus, plus 10y, and this must be less than or equal to 60 because there is a maximum of 60 people that can attend the conference. The graph below shows the 4 lines representing inequalities 1 to 4. Also shown on this graph are 4 of the integer points that satisfy inequalities 1 to 4. Each of these integer points is marked with a cross. Part B. On the graph above, mark clearly with a circle the remaining integer points that satisfy inequalities 1 to 4. These points have coordinates 3 and 4, 3 and 3, 4 and 4, 4 and 3, and 5 and 3. Each car will cost $70 to hire, and each minibus will cost $100 to hire. Part C. What is the cost for 60 members to travel to the conference? The only point on the line with equation 5x plus 10y equals 60 is the point with coordinates 4 and 4. That is 4 times 70 plus 4 times 100 equals 680. Part D. What is the minimum cost for 55 members to travel to the conference? We are going to use the point with coordinates 5 and 3, which gives 5 times 5 plus 10 times 3 equals 55 members, with a total of 5 times 70 plus 10 times 100 equals 650. The point with coordinates 3 and 4 is going to give us 55 members as well. That is 3 times 70 plus 4 times 100 equals 610. So this is the minimum value. Part E. Just before the cars were booked, the cost of hiring each car increased. The cost of hiring each minibus remained $100. All original constraints apply. If the increase in the cost of hiring each car is more than $k, then the maximum cost of transporting members to this conference can only occur when using 6 cars and 2 minibuses. Determine the value of k. The new cost equation is going to be c equals 70 plus k all multiplied by x plus 100y. The gradient of this line is going to be negative 70 plus k over 100. The line is passing through the point with coordinates 6 and 2 because there are 6 cars and 2 minibuses. The line with equation x plus y equals 8 is also passing through the point 6 and 2. X plus y equals 8 has gradient negative 1. Therefore, negative 70 plus k over 100 is less than negative 1. We solve this inequality and we end up with k equals 30.